Hello class, this is teacher Reggie. So today I'm going to discuss the chapter 1, which is database. I hope you listen carefully and also you learn something for today's topic. Let's take a moment to define what this database is. A database is essentially a collection of data that is organized for easy access, management, and updates. Think of it like a digital filing system. It keeps everything in order so you can find what you need quickly without unnecessary hassle. Now, to create and manage the database, we utilize something called Database Management Software, or DBMS for short. This software is important as it helps us maintain the integrity and efficiency of our data. As we move forward, we'll discuss the common problems that databases are designed to address. First, we face unnecessary duplication of data. This is not only waste space but can lead to confusion and inconsistency in our records. By organizing the data in database, we can eliminate this issue and ensure that each piece of information is stored only once. Next, there's the boredom and time wastage. While searching for records, imagine sifting through files of paper or endless files on a computer. A well-structured database allows for quick retrieval of information, making our work more efficient. Finally, we have misleading reports due to poor data entry and organization. When data isn't managed properly, the insight we derive from it can lead us astray. A robust database helps maintain accurate and reliable records so we can make informed decisions. Now that we've discussed these challenges, we'll move on to some common example of database management software. Next, as we move into discussion common of database management or DBMS, let's first recognize how important these tools are addressing the problems we outlined. First, Microsoft Access. Great for small to medium size. MySQL, an open source option that's very popular for web applications. Next, Oracle, known for its robustness and scalability, especially in enterprise environments. Whether you're looking for something lightweight like Lotus approach or more comprehensive system like Fox, there is a DBMS that fits almost every need. As we explore these options, think about which software you might find most beneficial in your own work or studies. Next, we'll proceed into specific function of DBMS, highlighting how they enhance database management and security. A DBMS is essential for managing data efficiently. First, it allows users to delete or add records, making it flexible for changing needs. Next, it enables users to update and modify existing records. This ensures that the information is always current and relevant. Additionally, a DBMS organizes data for easy access, retrieval, and manipulation of records. This is crucial for effective data management. as it saves time and reduces frustrations. Moreover, it ensures the security of data, which is increasingly vital in today's digital landscapes. Finally, it helps keep statistics of data in database, allowing for information decision making. So let's move to this discuss the different database models. Database models. In this model, a database contains just one set of data, which can be quite similar to how we manage manual files. It's important to note that files consist of records that lack of structured relationships. This means that the data is stored in simple format, typically with a small fixed number of fields. So, while flat files are straightforward, they can limit our ability to manage and relate data effectively. Are there any questions about flat files operate or how they differ from more complex data models? In this model, data items are organized in tree-like structure. To access a level 2 data item, you must first reach the level of data item, which we refer to as the root component. This structure hierarchical models quite intuitive in mirror how we often visualize relationships in nature and systems. Each child node can only one parent, but a parent can have multiple children. This model is particularly useful in scenarios where a clear, nested relationships is beneficial, such as organizational chart or file system. Next, we'll explore the network of model, which builds on this concept of relationships but adds additional flexibility. Here, relationships between the data items are expressed through links, which allows us to form a rich network of interconnected items. One of the main advantages of this model is that you can access a single data item through multiple paths. This flexibility can be incredibly powerful when working with complex datasets, as it allows for more efficient data retrieval. However, it can also introduce some complexity in terms of data management, which is something to keep in mind. As we transition from this network model, we'll soon explore the relation model, which take a different approach by organizing related data in tables. But for now, let's appreciate the unique structure that the network model provides. In this model, related data items are stored together in structure known as relations or tables. What interesting is how relationship can be created between these tables. This means that records from the one table can relate to others in different tables, allowing for more structure and organized way to handle data. This organization provides clarity and enhanced data integrity, making it easier to retrieve and manipulate information. So, as we transition to the next topic, keep in mind an advantage of this structure approach as we dive into object-oriented models. Object-oriented models present fresh perspective on database. They define a database as collection of objects. Think of these as entities that have features and methods. This approach allows for more intuitive organization of data. Additionally, we have the object relational model. This is an exciting hybrid that combines the best of both worlds. The familiar relational database model in some key concept from object-oriented design. It retains the structure of relational database but adds the flexibility and capabilities of objects. By adopting this model, we can take advantage of enhanced functionalities without falling into the complexity that often accompanies pure object-oriented systems. This makes it a practical option for any applications. Next, we will explore the features of TBMS software that support these models. As we transition into discussion of features of TBMS software, let's take a moment to appreciate how these tools empower us in managing our data effectively. So first, it's essential to understand that DBMS software provides critical functionalities that simplify database manipulation. Number 1. Data tables. These are the backbone of any data. They hold related data items organized neatly into Sorry for interruption. Tables are essentially the backbones of the database. They hold related data items in structured format. Imagine a table as a grid of information where each row represents a unique record and each column corresponds to a specific field of data. This organization not only makes data retrieval easier but also enhances our ability to analyze relationships between different data points. So, as you visualize these tables, think about how they function, like a well-organized filing cabinet where each drawer and folder is meticulously arranged for quick access. Now, keep this imagery in mind as we transition into the next key aspects of databases. Queries, where we will explore how to extract valuable insight from these tables. A query is essentially a statement that allows us to extract, change, analyze, or request specific data from one or more tables. Consider a scenario where you want to find out how many individuals in your database live in specific city. Or perhaps you're interested in seeing which individuals have registered within a certain time frame. The beauty of queries is that you can access this information either pragmatically or through a user-friendly interface. User-friendly interface to highlight accessibility. Queries are powerful tools that help us retrieve just the data we need, making our analysis much more efficient. Next, we explore how forms serve as a graphical interface to enter and view data. A form is essentially a graphical interface that mirrors a traditional paper form. It plays a vital role in how we interact with our data, allowing users to enter and view data seamlessly. Now, think about how much easier data entry becomes when we can visualize it in a familiar format. This is particularly useful for those who may not be tech savvy. Additionally, we have reports that carry the output from our database. These reports are crucial as they aid in decision making and analysis. To sum up, forms and reports are not just tools, they are essential components that empower us to work effectively with our data. Macros are powerful tools used to automate processes. Think of them as your personal assistant in the database, performing repetitive tasks efficiently which save time and minimize errors. As our database grows in complexity, we often need to take a step further. This is where modules come into play. Modules are programming language to provide even more advanced automations. They allow us to create custom functions and procedures, giving us greater control over our data management processes. So remember, while macros simplify tasks, modules enhance our capabilities, making our databases smarter and more efficient. Now, let's look ahead to how we organize our data within these databases. First, we start with the simplest unit, which is called a field. A field represents a single piece of data, like name or a date. Next, we move on the records. A record is a collection of related fields that together represent a single entity. For example, one record might include a person's name, address, and phone number. Finally, we have tables. A table is a collection of related records. Think of it as a way to organize all the information about specific type of entity. The hierarchical structure helps maintain clarity and accessibility as databases grow more complex. Are there any questions so far? As we dive into a concept of data organization with a database, let's start within the building blocks. Fields. Think of the fields of the smallest unit of data. It's a single character or a logical combination of characters that represent a specific data item. For instance, a field could be a name, a date, or a number. Records. Now, when we group related fields, we form a record. A record is essentially a collection of fields that together represent a single entity. This could be a row in a table capturing all relevant details about, say, a customer or a product. So, tables. Finally, we combine multiple records. We create a table. This is where I store related records in a structure in a way that allows for easy access and organization of data. These components are essential in understanding how data is structured, which is in turn is critical for effective database management. Now, before we move on the QAA, does anyone have any question about this fundamental concept? And that's all. Thank you. And I'm Teacher Reggie, and I hope you learn something new. Thank you.